So we'll have to just kick off now. We can't afford to wait for anyone again. So we'll continue from where we stopped yesterday. Still on system hacking. Still on system hacking, and we'll be looking at some aspects of system hacking. We have looked at password cracking. We have looked at the issue of buffer overflow. We have looked at different techniques for privilege escalation. Then we talked about some things that some tools, both hardware and software, that are usually used by um, NTFS alternate data stream. So this NTFS data stream is mostly a Windows stuff. Is for Windows. So if your system is Windows, you'll be able to do this. Unfortunately, I'm not using a Windows system, so I cannot demonstrate it. I would have demonstrated, but I'll just show you how you can try to do that. You can do that on your own and see how it works. It's very, very simple. So it's just a way of hiding files within files, hiding a file within a file. So this is part of what attackers do when they are able to gain access into a system. When they have been able to hack the system, they try to hide the file inside another file, and they do this by um, making sure that they create the usually notepad. So NTFS alternate data stream, Windows CD stream, which contains metadata for the file, such as attributes, word count, author name, and access, and modification time of the file. So alternate data stream can fork data into existing files. You can put data inside an existing file without changing or altering their functionality, size, or display to file browsing utilities. So alternate data stream allows an attacker to inject malicious code in file. Please mute your mic. Mute your mic. Allows an attacker to inject malicious code in files on an accessible system and execute them without being dictated by the user. So let me just show you how it is usually done. So this is just simple step. All you need to do, if you are using a Windows system, you launch your terminal, that's your command prompt. Once you launch it, just type this. Type it exactly the way it is here. So maybe by the time you're watching the recording, you can just pause and try it out. You may not be able to try it now. So once you do this, now you see that there's a file here. There's a file, my file.txt. My file.txt. And this my file.txt is the main file. So now you now hide another file inside my file.txt, which is lion.txt. Then you click yes to create the new file, enter some data, and save the file. So you once you do that, so this lion.txt, this you if you go to your maybe your files, or your files that contains your the folder that contains your files, you will still see my file.txt, but you will not uh, see lion.txt, because lion.txt will be hidden inside my file.txt. So, and if you have not put anything, maybe you have not written anything in my file.txt, it will just be reading zero. So if anybody checks it, it will still be zero. But you can write a lot of things in this lion.txt, and nobody can open this lion.txt ordinarily. If they click on my file, they will just see an empty something. So that's how attackers hide files inside files. So you can also try it again. My file.txt, you can also hide this tiger.txt in my file.txt. So view the file size of my file.txt, it should be zero. So if you now want to modify lion or tiger.txt, all you just need is to type notepad my file.txt : lion.txt, and it will open up that file. for you, this lion.tsc or tiger.tsc. So that's how it's a simple stuff. You can just give it a try. I'm sure it will you work. It just let's work on that, and I'm sure it's something that you'll be able to do. But if in case you're unable to do it, just reach out to me. You can reach out to me on the group, and let's look at it together. So maybe you share your screen. I'll see what's on your screen. So also another system is for us to do. You can use it for stream manipulation, NTFS stream manipulation. Now you have this is a malicious file, trojan.exe, and you want to move the contents to readme.txt, which is 0, and the location is C. So you just say C, then type C trojan.exe greater than sign C readme.txt, then trojan.exe. So you have embedded this trojan into readme.txt. Then for you to create a link to the trojan that is inside this readme, remember readme is text, is size 0. There's nothing there. So inside the readme.txt file, you say mklink, make link backdoor.exe. Yes, readme.txt trojan. So this backdoor is now the link to this trojan.exe. So to execute the trojan, all you just need to do is to type C, then backdoor, then it will just open up trojan.exe. So that's how that works. So that's how you hide files inside files. So that's how you hide files inside files. So that's what NTFS is all about. So please do try it and let me have your feedback. So how do we defend against this kind of manipulation of alternative data streams? To delete NTFS streams, move the suspected files to the FAT partition. There's a partition in your computer that is FAT partition. You can move it there. You can use a third-party file integrity checker such as Tripwire File Integrity Manager to maintain the integrity of an NTFS partition files. So if you have that tripwire, so that tripwire helps you to look at the integrity, because it would have created a signature of the file initially, such that anytime any manipulation is done, then once you compare it, you'll be able to see that something has been done. There has been a manipulation somewhere. Then use programs such as Stream Detector or GMA to detect streams. You can use programs such as Stream Detector or GMA to detect if there are streams, if there are hidden files within files. They enable real-time antivirus scanning to protect against execution of malicious streams in the system. Then you use up-to-date antivirus software on the system. Use up-to-date antivirus software on the system. So that's the countermeasure. Then you have NTFS stream detectors. Stream Armor can help you to detect if there's discover hidden alternate data streams and cleans them completely from the system. Stream Detector, GMA, ADS Manager, ADS Scanner, streams. So Stream Armor is a tool used to discover hidden ADS and clean them completely from your system. It's advanced auto analysis coupled with an online threat verification mechanism. Helps you to eradicate any alternate data streams that may be present. As shown in the screenshot, security professionals use Stream Armor to analyze and detect ADS streams in their systems. So they use it to analyze and detect ADS streams in their systems. So you can see that it's analyzing all the system, and you can see what the ones it highlighted in red is showing that Look, I don't know if you can see this readme.txt, the x.txt. So that means this x.txt is reading inside readme.txt. Okay, then we move to steganography, which is another thing that attackers want to do. Yeah, what steganography is just using images mostly to cover the message. So you see an image, you feel that it's just an image, but far from it, it has other hidden messages even behind it. So it's the technique of hiding a secret message within an ordinary message and extracting it at the destination to maintain confidentiality of data. So it's a technique of hiding a secret message within an ordinary message and extracting it at the destination to maintain confidentiality of data. So utilizing a graphic image as a cover is the most popular method to conceal the data in files. So the attacker can use steganography to hide messages such as list of compromised servers, source code for the hacking tool, or plans for future attacks. So so that's steganography. So mainly using another um, using a public image as a cover. So utilizing a graphic image as a cover is the most popular method. So hiding messages within images. So it's not only images, they hide it within documents, within applications, within audio and video files. So they can hide messages there. So you can see what we have here. You see the cover medium, which could be pictures, it could be audio file, it could be, let me get a bigger one. Okay, you can see it could be PNG pictures, picture, audio, a document, HTML, and video. So this is the message that is to be hidden. I believe you can see my cursor. Then the embedding function. There's an embedding function which makes hides this message within this cover medium and turns this into a stego object. Then at the other hand, you have an extracting function which separates the message even from the cover medium. So steganography refers to the art of hiding data behind other data without the knowledge of the victim. So it hides the existence of the message. It replaces bits of unused data into ordinary files such as graphics, sound, text, audio, and video with other surreptitious bits. The hidden data can be in form of plain text or ciphertext. So it can be either a plain text message or an encrypted message, and sometimes an image. So utilizing a graphic image as a cover is the most popular method to conceal the data in files. Unlike encryption, the detection of steganography can be challenging. Thus, steganography techniques are widely used for malicious purposes. So, attackers also use steganography to hide information when encryption is not feasible. So, when you cannot encrypt. So, we have different classification of steganography. We have linguistic steganography, we have technical steganography. So under linguistic steganography, we have semagrams, open code, visual semagrams, covered ciphers, text semagrams, jargon code. The other covered ciphers, we have null cipher and grill cipher. So it can be technical or linguistic. That steganography can be technical or linguistic. In technical, message is hidden using scientific methods, whereas in linguistic, it is hidden in a carrier, which is the medium used to communicate or transfer messages or files. So the medium comprises of the hidden message, carrier, and steganography key. So there's a key that is used to embed the secret message into uh, the cover medium. So we have the hidden message, the carrier, then the steganography key. So under technical steganography, where we have what we call um, the use of physical or chemical methods to hide the existence of a message. So this the chemical method may include invisible ink. So the like our currency, I think we're all based in Nigeria, yeah. All of us were all Nigerians. So we're all Nigerians. So um I believe we can all understand when we say that um when we talk about our currency, the currency, we see that sometimes if you the currency, if you put it under maybe a blue light, you will see visible to the eye. So that's a form of technical steganography. Use invisible ink or security ink. So use invisible or security ink. It's used for invisible writing with colorless liquid and can later be made visible pre-negotiated manipulations as lighting or eating. Then you can use micro dots uh, to also hide the things you want to hide. Is a microdot is a text or an image considerably condensed in size, fitting up to one page in a single dot to avoid detection by unintended recipients. Microdots are usually circular and about 1 millimeter in diameter, but can be converted into different shapes and sizes. So, computer-based methods. A computer-based method makes changes to digital carriers to embed information foreign to native carrier. So communication of such information occurs in the form of text, binary files, disk and storage devices, and network traffic and protocols. So it can alter software, speech, pictures, video, any other digitally represented code for transmission. So so that's computer-based methods. So just basically using of computer to make changes to digital carriers to embed information that are native to them. I mean that are foreign to them. So we have different types of computer-based steganography techniques. We have substitution. You try to encode secret information by substituting the significant bits with the secret message. So we have some insignificant bits that if you remove from that particular cover image or cover document, it will not affect it. So those significant bits are where we now put in the message we want to hide. So um, so that's substitution. So you substitute the insignificant bits with the secret message. So if the receiver knows the places where the attacker embeds secret information, he or she can then extract the secret message. Then transform domain technique. This transform hides the information in significant parts of the cover image, such as cropping, compression, and some other image processing area. It makes it more difficult to carry out attacks. So there are some significant areas. So, but we can crop or compress it so that there will be, it will create space. Then spread spectrum technique is less susceptible to interception and jamming. Communication signals occupy more bandwidth than required to send information. So sender increases the band spread by means of code. And the receiver uses a synchronized reception with the code to recover the information from the spread spectrum data. Statistical techniques utilizes the existence of one bit steganography scheme by modifying the cover in such a way that when transmission of one occurs, some of the statistical characteristics change significantly. In other cases, the cover remains unchanged to distinguish between the modified and unmodified covers. Distortion techniques, the user implements a sequence of modifications to the cover to obtain a stego object. So then linguistic steganography. This type hides the message in the carrier of another file. Further classification includes semagrams, involves a steganography technique that hides information with the help of signs or symbols. So we use signs or symbols to hide information. The user embeds some objects or symbols in the data to change the appearance of the data to a predetermined meaning. So the visual semagrams, this technique hides information in a drawing, painting, letter, music, or symbol. So that's visual. You hide it inside a drawing, painting, letter, music, or symbol. Text hides the message by converting or transforming the appearance of characters message, such as by changing font sizes and styles, adding extra spaces as white spaces in the document, including different flourishes in letters or handwritten notes. Then open quotes hides the secret message in a legitimate carrier message specifically designed in a document that is unclear to the average reader. So that the person that wants to read it, he will not, unless he is in the know of the kind of steganography technique that was used. So here, this carrier message is known as overt communication, secret message as in covert communication. The open code technique consists of two groups, jargon codes and covered ciphers. Then jargon codes. In this type of steganography, certain language is used that can be understood by the particular group of people to whom it is addressed. So that's a jargon. So when you're talking of a jargon, that's something that is specific to a particular group. That's a jargon. So that's a jargon. When you're talking of a jargon, it's something that is specific to a particular people. Like now, if I'm saying scientific jargons, so that means the people in the science of mathematical jargons, there are languages they use that all people, every day person doesn't use. So they use that. A jargon message like substitution cipher in many respects, but instead of replacing individual letters, the word themselves are changed. So example of a jargon code is Q code. A Q is a word that appears in the text and transforms it. So it's a Q, like giving somebody a sort of sample of the answer, a cue, something that will jog that person's memory, help the person to know what the answer is. Then covered cipher. This technique hides the message in a carrier medium visible to everyone. It can be extracted by any person with knowledge of the method used to hide it. Further classification of covered ciphers include null ciphers and grill ciphers. So let's just move on. Okay. Types of steganography based on cover medium. Depending on the cover medium, it can be image steganography, so you use an image to cover the hidden message. Document, you use a document. Folder, you hide in folder. Video, you use a video to cover to hide the message. Audio, you use audio files, whether WAV.mp3. Which other audio file format do we have? MP3, okay. Then white space, you hide it within white spaces. Web steganography, spam soak email steganography, DVD-ROM steganography, natural text steganography, hidden OS steganography, C++, source code steganography. So we have steganography tools. We have white space, um, white space steganography. We have image steganography and document steganography. So white space steganography is used to conceal messages in ASCII by text by adding white spaces to the ends of the lines. Because spaces and tabs are generally not visible in text viewers, the message is effectively hidden from casual observers. So if built-in encryption is used, the message cannot be read even if it is detected. So we will hide it in white spaces, and these white spaces you can't, when you are using text viewers, you can't see the white spaces. So that's the issue. So tools that can be used for that include Snow. It's used for concealing messages in text files by appending tabs and spaces to the end of lines, and for extracting messages from files containing hidden messages. is and for extracting messages from files containing hidden messages, for concealing messages in text files, by appending tabs and spaces to the end of the line, for extracting messages from files containing hidden messages. So the user hides the data in the text file by appending sequences of up to 7 spaces. So they use spaces majorly to just cover up the file. So this white snow. So you can see the message that is to be hidden is my Swiss bank account number is so 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 so. So the pmagic readme.txt readme2.txt compressed messages in the available space and extra 8 lines were added. So that's what they use. So you put in the message that you want to put in the message, the in file, the out file, compress C, compress the data type concealing, Q quiet mode, S report the approximate amount of space available, P password, L line length, F message file, M message string. Image steganography, most popular cover objects used for steganography, allows you to conceal your secret message within an image. You can exploit the redundant bits of the image to conceal your message within it. These redundant bits are those parts of the image that have very little effect on it if altered. The detection of this alteration is not easy. You can conceal your information within images of different formats. PNG. So you can use let's look at it. Okay, look at how it works. You have the cover image, you have the information you want to hide, you have the steganography tool. It hides this inside this, and it gives you a result stego image. So if the person at the other end wants to also see it, he has to use the steganography tool to separate the information from the cover image. So image steganography tool will have OpenStego, is a steganography application that provides the following functions: data hiding. You can hide any data within a cover file. Watermarking files with an invisible signature can be used to detect unauthorized file copying. So the watermarking with an invisible signature can be used to detect unauthorized file copying. Then so that to Stego online. So you can see the screenshots here. This is the message file that you want to hide. This is the image you want to use to cover it. Then this will be the output. This will be the output. So you can either use it to hide the data or to extract it. So you can also use it to watermark. You can also do document steganography, hide file messages within a document, video, hide within video. This and the two that can be used omni hide. This is the file to hide. This is what you want to hide. Then the output file. So you want to hide this. This is the mask file. That's this cover image. The audio also is the same. You can put the information as an audio file. It becomes a stego object. So that audio file is not just an ordinary audio file. It carries a message. So tools for that, we have deep sound. Deep sound. So we have audio. Then you have secret file.pdf, secret file.doc, secret file.jpg. So output directory document. So these are the carrier audio files. You want to hide this inside them. So that's what it does. Then folder, it refers to hiding secret information in folders. Files are hidden and encrypted within a folder and are not seen by standard Windows application, including Windows Explorer. Here, the user moves the file physically, but still stays associated to its original folder for recovery. So it is moved, but still stays there. So you hide it within the file. You hide it. So that examples of folder steganography tools: folder lock, hide folder, 5 visible secrets, quick crypto. So our spam stroke email steganography refers to the technique of sending secret messages by embedding them and hiding the embedded data in spam emails. So various military agencies use this technique with the help of steganography algorithms. You can use spam mimic to hide a secret message in an email. So spam mimic is spam grammar for mimic engine by Peter Wiener. It encodes secret message into innocent looking spam email. So somebody may feel that you are sending a spam email that's unsolicited pornographic and advertisement messages, but actually you are sending um excuse me, secrets that you don't want people to know. So the encoder of this tool encodes the secret message as spam with password, fake PGP, fake Russian, and space. So this is short secret message. So you can encode it as a spam with a password, encode as a fake spreadsheet, encode as fake PGP, encode as fake Russian, encode as a space. So spam mimic allows you to do that. You can encode it as a spam. So you can see this. This is a message. It gets encoded into spam as well. Anybody that intercepts it will see this, but this is more than what it is. So we have other types of steganography, web steganography. User hides web objects behind other objects and uploads them. DVD-ROM steganography. User embeds the content in audio and graphical data. Natural text. Process of converting sensitive information into user-definable free speech, such as play. As a play, hidden OS steganography is a process of hiding one OS in another. C++ source code steganography. User hides a set of tools in the files. So we have tools for if you may want to use your mobile phone to hide files. We have Stairgaze. So you can try to download the Stairgaze, can hide the message in a selected image from the photo library. So if you want to hide maybe a message, so you can choose what type of message you want to hide inside the image. Is it text or voice you want to hide? Or you can go to the review message from the review. You can go to review the message from your image. So this will help you to decode. This will help you to encode the message. So Stairgaze, you can check for it on your mobile phones, the Android. Other ones, SpyPix, Pixel Note, steganography, no clue, photo hidden data. So we have what we call steganalysis. Steganalysis is a reverse steganography. You have seen a stego object. Now you want to break it down to review the message, and you are not aware of the stego algorithm or stego, what was used even to perform the steganalysis or the tool that was used. So there's Steganography is the reverse process of steganography, art of discovering and rendering covert message using steganography. So it detects hidden messages embedded in images, text, audio, and video carrier mediums. It detects hidden messages embedded in images, text, audio, and video carrier mediums. So what are the challenges of steganalysis? The things that are challenges here include suspect information stream may or may not have encoded hidden data, and the efficient and accurate detection of hidden content within digital images is difficult. The message could be encrypted before being extracted. So if you are looking at a message that you saw a stego object, I say, okay, by the time you reverse this steganography, or you will just get the message. But there may be a challenge. The challenge may be that the message may have been encrypted before it was put through the steganography process. So that could be an issue. Then some of the suspect signals or files may have relevant data or noise encoded into them. So those are the challenges for um, steg analysis. So steg analysis has two aspects: detection and distortion. In the detection phase, the analyst observes the relationship between the steganography tools, the stego media, cover, and message. So you have this steganography tool, which is used even to uh, embed the stego object. Stego message or cover, message into the stego uh, media. Then you have the cover, you have the message. So that's for detection. You want to know what's the relation between the steganography tool, the cover, and also the message, and also the stegometer. That's the eventual when the cover and the message, secret message, are embedded together, you get a stegometer. So in the distortion phase, the analyst manipulates the stegometer to extract the embedded message and decide whether it is useless and should be removed altogether. So that's the distortion and detection. So he wants to look when he wants to extract the embedded message and decide whether it is useless and should be removed. So there are two types of attack against steganography. We have message and chosen message attacks. So in message attack, the steganalist has a known hidden message in the corresponding stego image. He has a known, that means he knows the message that is hidden. So that's a message attack. So it determines the pattern that arises from ID and detecting the message. It creates a message using a known stego to analyze the differences in patterns. In choosing message, it creates steganography media using the known message and steganography tool. So in message, it determines the pattern that arises from ID and detecting the message. It creates a message using a known stego tool and analyzes the pattern differences in pattern. So cover images disclose Cover images disclose more visual clues than stego images. So that's just the process of steganalysis. So steganalysis methods stroke attacks on steganography. We have stego only. That means the when you talk about stego object, you're talking about the product of combining a secret message and also a cover medium, whether it be audio, video, or white space, whatever. So that's stego object. Knowing only the stego object, when stego only the stego object is available. Non-stego, the attacker has access to the stego algorithm and both the cover medium and the stego object. He has access to the stego algorithm. That's the algorithm that was used to make the stego object, and both the cover medium and stego object. So, but he does not have access to the message. No message, he has access to the hidden message and the stego object. Non-cover, he compares the stego object and the cover medium to identify hidden message. Chosen message, he generates stego objects from a known message using specific steganography tools in order to identify the steganography algorithm. So he wants to compare It wants to compare if the output, once the output uh, is the same, if it tries a particular algorithm using a particular message and the output to what he saw is the same, he will know the particular algorithm that was used. Choosing stego, he has access to stego object and stego algorithm. That chi square performs probability analysis to test whether the stego object and the original data are the same or not. Distinguishing statistical. The attacker analyzes the embedded algorithm used to detect distinguishing statistical changes along with the length of the embedded data. A blind classifier. A blind detector is fed with the original or modified data to learn the resemblance of original data from multiple perspectives. So how do we detect steganography? Text file. For text files, the alterations are made to the character position to hide the data. You remember there are some spaces and they can be substitution. We talk about substitution or using of different spaces. The alterations are detected by looking for text patterns or disturbances, language use, and an unusual amount of blank spaces. Image file. The hidden data in an image can be detected by determining changes in size, file format, the last modified timestamp, and the color palette, pointing to the existence of the hidden data. The hidden data in an image can be detected by determining changes in size, file format, the last modified timestamp, and the color palette, pointing to the existence of the hidden data. So the statistical analysis method is used for image scanning. So we want to look at are there changes in size? Of course, when you combine a message with an image, there may be changes in size or file format. So, and last modified timestamp, of course, if there's a modification, you'll see it in the last modified. The audio file, the statistical analysis method can be used for detecting audio steganograph as it involves LSB modifications. The inaudible frequencies can be scanned for hidden information. Then video file, detection of secret data and video file includes combination of methods used in image and audio. So in image, we'll talk about looking at the changes, last modified, change in size, file format, and all that. In audio, we talk about LSB modification, inaudible frequencies, odd distortion, and patterns. So tools to detect steganography, ZSTEG to detect stegano hidden data in PNG and BMP image files. ZSTEG. You can use it to determine the hidden messaging and hidden in the image file. So you can see passing. This is a stego object. You now look at it, you can see the text that are hidden. Second cat is Marusha, good, but look at video deeper. Velo thought kitten is Bessie. So C-Tech can help you to do that. Steganography detection tools. Okay, so we have moved from steganography. Then we'll talk about, if you recall our CEH methodology, you do reconnaissance, you do scanning, you do uh, enumeration, you gain access, then you maintain access. So you gain access and you maintain access. So we're talking about gaining access, all these things we're talking about. Then the issue of steganography is for hackers to be able to hide what they are doing. You understand, hiding what they are doing in another in the system that has been compromised. So they're able to hide files. That's the same thing we also talk about when we're talking about NTFS alternate data streams. So, but we want to talk about this maintaining uh, access now, maintaining persistence. That's you are able to do what you set out to do as an attacker without the interruption of the owner of the system that has been compromised. So attackers abuse system boot or logon or to start program for escalating privileges and maintain persistence by applying custom configuration settings on the compromised machine. So it allows attackers to automatically run a program at the time of system boot or logon. So attackers use two methods for abusing boot or logon. Either they use registry run keys or startup folder. So what happens is that normally when uh, they install many of these things upon shutting down the system and all that, and all those things that are being installed, the tools that are being installed, all to stop working. But they have a way of manipulating such that whenever you restart the system or boot it, such tools that are being used even to compromise the system also start up with it. So, so attackers create persistence by executing malicious code on the target device by tricking the victim into accessing a malware loaded file or downloading a malicious program. So the persistent enables attackers to infect different components of the system continuously and to remain undetected against any defensive solution. Once persistence is successfully established, a backdoor channel is created for the attackers through which they can perform malicious activities as the malware replicates itself, even if the target system reboots. So that's what I'm saying. Once, even if it reboots, they are able um, to still uh, do what they are supposed to do. So just give me a second. Okay. So another means they do this is through domain dominance, through different paths. This is a process of taking control over critical assets such as domain controllers on the target system and gaining access to other networked resources. So attackers employ social engineering techniques to launch domain dominance attacks through an internal user. So they take over critical assets such as domain controllers on a target system and gain access to the network resources. They employ social engineering techniques to launch domain dominance attacks through an internal user. So we have attacker does remote code execution commands to a legitimate user to the domain controller. So by this, is able to gain access to the domain controller. So domain dominance techniques, we have remote code execution, like this example here, abusing data protection API, malicious replication, skeleton key attack, golden ticket attack, silver ticket attack. So attackers often focus on gaining complete access over domain admin staff accounts to launch attacks on the target network. Subsequently, attackers can perform data pocketing, malware injection, service denial attacks, etc. Further, attackers also attempt to maintain dominance to hold persistence over time on the domain controllers. Remote code execution. Attackers attempt to execute malicious code on the target domain controller through command line interface to launch um, a domain dominance attack. So they have a tool they can use to do remote code execution. Then abusing the data protection API, we have Windows domain controllers contain a master key to decrypt DPAPI, that's domain data protection API. So attackers attempt to obtain this master key from the domain controller. So we'll talk about remote code execution. Attackers attempt to execute malicious code on the target domain controller through CLI to launch a domain dominance attack. Using this technique, attackers hold persistence to perform malicious activities over time without being detected. They follow steps below to perform domain dominance attack via remote code execution. So they create a dummy process and the user on the target domain controller using Windows management interface. So domain controller name, this is the name of them, process co-create, net user, add pariter process, dummy process and user. So this is the pariter process, this is the user. So pariter process is the user ID and DUYO1 is the password of the dummy process. Once it's created, they add the user to admin group. Then navigate the Active Directory user and computer and identify the user created using the above command. They open the properties windows on the system and navigate to member of to verify the membership. So they want to know if this new user has been added to the admin group. So you can see member of domain admin. So remember the created user. So after successfully adding a new user to the admin group, the attacker uses these credentials to hold persistence on the target domain controller. So they use it to hold persistence because they have added that particular user to the admin. Then DPAPI, a unified location in Windows environment where all the critical graphically secured files, password of browsers, and other critical data are stored. So here you have all files and full password of browser and all that. They are stored in DPAPI. So Windows domain controllers contain master key to decrypt the DPAPI protected file. So this master key is what they are looking for because they want to decrypt the storage of all this very, very critical information. So use Mimikatz to recover the master key using the password of a compromised user. DPAPI master key and backup keys system offense local export private export. It gives them the keys. To cross-check whether the secured master keys are obtained by navigating through the root location containing the mimikatz.exe file and check for file formats such as .der, .key, pvk, and .pfs. By obtaining a master key, attacker can open any DPAPI encrypted file from any device associated with the network and maintain persistence. Malicious replication and skeleton key attack. Malicious replication, it enables attackers to create an exact copy of user data using the admin credentials. So attackers often attempt to replicate sensitive accounts such as KR, BT, GT. So that's malicious replication. You create an exact copy of user data using the domain credentials. The skeleton key attack, form of malware that attackers use to inject false credentials into domain controllers to create a backdoor password. It's a memory resident virus that enables an attacker to obtain a master password to validate themselves as legitimate user domain. So skeleton key. So use a malware to inject false credentials into the domain controllers and create a backdoor password that the attacker can always use to come back in. So it's also mimikatz that will be used. It's a backdoor password. We have golden ticket attack. This one is an attack against the Kerberos. I'm okay. And the Kerberos because the post exploitation technique implemented by attackers to gain complete control over the entire Active Directory. Attackers forge ticket granting tickets by compromising key distribution service accounts to access various Active Directory resources. So we have it gathers the domain name and SID and then impersonates the privileged user. Then attackers steal the KRBTGT password and send a forged ticket granting service request. Then they get a response. Then the attacker accesses resources as a legitimate user. Another way for them to maintain domain persistence is admin SD holder through admin SD holder. So it's an object of Active Directory that protects users' accounts and groups having high privileges against accidental modifications of security permissions. It protects user accounts and groups having high privilege against accidental modification of security permissions. So attackers having admin privileges on a compromised domain can abuse the SD prop process to establish persistence. So all these things they were talking about is just for the attacker to be able to uh, maintain persistence, to be able to do what it's doing. It doesn't want to be kicked out of that domain that he has been able to get into. So that's all what all this is all about. So attacker having admin privilege on a compromised domain can abuse the SD prop process to establish persistence. Attackers can add a user account to the access control list to gain generic or privileges like administrator privilege. So this does the same thing we saw earlier on where they used, what was that? Remote that through remote code execution. So it's almost the same thing that we have here through admin SD holder. Attackers can add the user account to the access control list to gain generic or privileges equivalent to the privileges of the domain administrator. We have other methods, maintain percent through Windows manual instrumentation event subscription to execute malicious content and maintain persistence on the target network. You can either use command prompt and power lock. So it creates a malicious namespace and subscription for the event. So Attackers use WMI to execute malicious content and maintain persistence on the target system. They use various scripts and techniques to exploit the features of WMI and perform event subscriptions for malicious events that, when triggered, initiate the execution of arbitrary code, allowing attackers to maintain persistence. These scripts automate the process by hiding malicious payloads and maintaining sustainability even after rebooting and restarting the system. So that is different types of other attacks. So for post exploitation for Linux systems, after exploiting them, what are the things you can do to file system commands? You want to discover the SUID executable binaries. Find PAM 4000 LS2. They have no. Disable write access to a file. Gmod OW file. Find .txt. Discover .txt files on the system. So find iPhone name .txt ls2. Sudo l displays the list of permitted and forbidden commands. Then information gathering commands on Linux. PSEF displays the current processes you attach a file system to the directory. Route N displays host stroke network names in numeric form. Cat stroke etc stroke cron tab displays running job. Other file system comma open SSL S client connect host name port displays source certificate details key to list key store displays contents of key store files and alias names. Displays cat SSH displays SSH relationships and login details. For Windows post exploitation file system commands, we have directory AH. If you type directory H in the command line interface, it retrieves the directory names with hidden attributes, then finds e.txt, txt.txt retrieves all the text files, find strE.log greater than log.txt retrieves all the log files, find strE.doc retrieves all the document files. So doc.txt is for document, log.txt is for log files, text.txt is for text files. Then WMIC to reboot Windows, WMIC OS where primary equals to true. Reboot WMIC node product get name version vendor displays the details of the installed software. WMIC CPU get retrieves the processor details. WMIC user account get name. It use login names and their SID, that session IDs, and so on and so forth. How do we defend against persistence attack? Frequently change the password of KRBTG, KRPTGT. Use admin credentials only if the data needs to be shared among the devices. Give access permission based on user roles. Perform system patch management periodically. Deploy a minimum privilege access model which assists in restricting user access and domain admin access. Monitor Kerberos, TGTs, and domain replication activities. Regularly change KRBTG's password and reset the service twice. Validate The Kerberos protocol externally to ensure TGTs are not forged. Conduct security awareness campaigns and training on phishing attacks, password creation, policies and other methods. Strictly adhere to password policies in terms of password length, periodic updates, etc. Ensure that Kerberos follows signing of the privilege attribute certificate. Deploy the Kerberos validation tool for verifying legitimacy of individual tickets provided by a valid KDC. Install KB 2871997 patch in systems running on Windows 7 for restricting. This is for restricting default account access within the local administrator group. Restrict credential overlap within systems to limit lateral movement. So lateral movement is the attackers are able to compromise the system and now wants to move to the next one. Impose user access account limitations across the local accounts over network logon by enabling a pass the hash mitigations, then restrict domain users within a local administrator group across multiple systems. Limit the inbound traffic through Windows firewall. So now the attacker has been able to gain access to the system, but it doesn't want to be found out. It doesn't want anyone to know what he has done. So he needs to clear the logs. He needs to clear the logs. Um, in previous section, we because these logs are just like when you visit government offices in Nigeria. What happens? They will tell you to sign. You sign in, you sign out. That's a form of log. So it happens also on a computer. Anything you do, there's a record of everything that happens on the computer. So, but the attacker doesn't want those records kept because they can implicate him, they can lead uh, law enforcement agencies to catch up with him. So, what it does is to try to clear the logs so that there's no evidence that can point to his activity. So, in previous session, we saw an attacker can hide malicious files on a target computer using various steganographic techniques, NTFS streams, and other techniques to maintain future access to the target. So once the attacker has succeeded in performing this malicious operation, the next step involves removing any resultant traces or tracks in the system. So to cover tracks, once the intruder has successfully gained administrator access on the system, they will try to cover their tracks to avoid detection. So he uses the following technique to cover his or her tracks on the target system. So he tries to disable auditing. So there's an auditing that takes place on every system. He can try to disable that, or he can try to clear the logs manually, or manipulate it, or cover track on the network operating system, or delete files or hide artifacts, or disable Windows functionality. So disable auditing, he can use audit pool to audit polls. So intruders disable auditing immediately after gaining administrator. Once they gain administrator privileges on the system, they want to disable auditing. They want to disable auditing. So one of the first steps for an attacker who has command line capabilities to determine the auditing status of the target system, locate sensitive files such as password files, and implant automatic information guarding tools such as keystroke logger and network. So we have audit pool can use to change audit security settings at the category and subcategory levels. So the attackers disable auditing with the help of audit pool. Once they complete their mission, they turn on auditing using the same tool. For enabling system auditing, audit pool set category system account logon sources enable failure enable. So that's to enable it. Then to disable it, success disable, failure disable. This will make changes in various order and register the attacker's action. He or she can choose to hide the registry keys change later on. Attackers can use audit pool to view the find auditing settings on the target computer, running the following command at the command prompt: audit pool get category. Screenshots of the output by audit pool as follows. So when it says success disabled, failure disabled, that's the command. That means you have disabled auditing. So you can see all the different types of auditing are no longer done. Security state change, security system extension, system integrity, and all that. So they are all disabled. So you can use audit pool for that. Then clearing logs. You can use the clear event viewer logs to clear the security system and application log. So if the system is exploited with Metasploit, the attacker uses Metapreter shell to wipe out all the logs from a Windows system. The attacker uses clear event log commands to clear all the PowerShell event logs from local or remote computers. He uses the web2til utility to clear event logs related to the system, application, and security. So to clear entries from PowerShell event from a local or remote system, clear event log Windows PowerShell. So to clear specific multiple log types from local and remote system, clear event log, log name, host session, host diag, computer name, local server, out. So to clear all logs on specified systems and display the event log list, clear event log, log name, application system, confirm. The attacker uses web2til utility to clear event logs related to the system, application, and security. So how do you do that? You download clear events viewer logs.bat, obtainforums.com, block the file, click on press and hold on the .ps and click on tab as one as administrator. If prompted by user access control, click yes. A command prompt will open to clear event logs. The command prompt will automatically close when you are through. You can also use Metapreter shell. You launch it from the Metasploit framework. That's Parrot, I hope. We have tried to install our Parrots. If you have any issues doing that, just reach out to me on the WhatsApp group. So, okay. You can also manually clear the event logs. If you go to Windows system, you see control panel, system and security, Windows tools, double click event viewer. Delete all the log entries logged while compromising the system. So control panel, system and security, Windows tools, double click event viewer. So that will allow you to delete all log entries logged while compromising the uh, system. So control panel, system and security, Windows tools, double click event viewer. So there you see all the um, logs that have so far gone. Then for Linux, var.log directly on the Linux system. Open the plain text file containing log message with text editor. Var log file name.log. Delete all log entries log while compromising the system. So everything, every details of all that the attacker has done will just be wiped off. So you can see Windows Event Viewer, Windows Control Panel, System and Security, Windows Tools, Event Viewer. You're able to see, you can see per time. This is a single date. We'll look at it 11/21, 11/21. Everything that happens, you can now clear it. Excuse me. Then you can also clear online tracks. Just give me a second. Let me just take water. I'll be right back. Okay, so you can clear online tracks. You remove the most recently used, delete cookies, clear the cache, turn off autocomplete, and clear the toolbar data from the browser. So for Windows, from the privacy setting in Windows, click on Start button, choose Settings, click on Personalization. In Personalization, start from the left pane and turn on both Show Most Used App, Show Recently Opened Items in Start, Jump List, and File Explorer. So with that, it will, because Windows keeps record of so many things like recently opened items, most used apps. So you can turn them off. Then from the registry, open registry editor, navigate to H key, local, machine, software, Windows, and then remove the key for recent docs. Then delete all values except default. Also cover bash shell tracks. Bash is an SH compatible shell that stores command history in a file called bash_history. You can view the saved command history using the more bash history or the _history command. Attackers use it to clear the saved command history tracks. Can clear the user's complete history. Start dev null, bash history, and exit. Also, another way to cover tracks on a network is by using HTTP reverse shells. So, attacker installs a reverse HTTP shell on victim's machine, which is programmed in such a way to ask for commands from an external master who controls the reverse HTTP shell. The victim will act as a web client who is executing HTTP GET commands, whereas the attacker behaves like a server and responds to the request. This type of traffic is considered as normal by the organization's network perimeter security controls like DMZ, firewall, etc. So the attacker uses an ICMP tunneling technique to Use ICMP echo and ICMP reply packets as a carrier of the TCP payload to access or control systems stealthily. So you can either use ICMP, that's Internet Control Message, which is used to determine if a host is alive or not, pinging or something like that. You can use it to cover your tracks. You can use it to cover your tracks. Then all this covering tracks is about what's it called? On the network, if you're on the network, so that you can be able to access it without being discovered. So you can use HTTPS, you can use ICMP, you can use DNS. Normally, the DNS is for when we want to try to access a website from your computer, you type in the domain name, but computers don't communicate using domain name. They communicate using IP addresses. So um, because of that, um, because of that, what converts domain name into IP address is what is called DNS, which is domain name service. So, but this domain name service, of course, it's not to be blocked, especially when you're talking about a web server. So attackers can use it to encode malicious content or data because it's usually open, because it's a normal service that is needed. So um, DNS internally creates a back channel to access a remote server and applications. Attacker can make use of this back channel to exfiltrate stolen, confidential, or sensitive information from the server. The TCP parameters, there are different TCP parameters that one can also try to manipulate. They can be used by attacker to distribute the payload and to create cover channels. TCP fields where data can be hidden include IP identification field, TCP acknowledgement number, and TCP initial sequence number. So they can be used to cover the tracks. And covering tracks on operating on an operating system, Windows. We talked about this already. Alternate data stream, NTFS. You can use it to hide things. So you can see here, secretfile.txt. Now, legit file.txt, secret file.txt. Here, the file is kept in C drive, where the secret file txt is hidden inside legit file. So you can see secret file, then legit file. So this hides this. So to view the file, type more, C secret file.txt. For this, you need to know the hidden file name. So you can't just identify the what's it called, secret file, maybe from the folder. You can't open from the folder. It has to be opened through the command prompt. So you have to know it. But for you to be able to identify it, you need to have a name which you can use to access it. So, and that's why you use this more secret file.txt to open it, to have to view it. Also, in Linux or Unix, by just appending a dot before a file, you can hide it. You can hide the file. Let me show us that. So Where's that? Okay. So a smart attacker knows how to overcome such a it does so by spotting its size equals to zero command. So I can't really see some of this. So, but this one modifying date and time, touch AD date. The above command is useful for changing the access time of a specific file. Using the touch command, attackers can change the date and time as per their requirements. So it's only this command is executed only if the attacker can manage to steal admin credentials. So it's only with admin level this thing you can do that. So admin can also use this one to change the date and time of last modification to mislead security provider because if they see the last time, I mean the time of last modification can help them to know if somebody else has accessed that file or not. Then also you can use cipher.exe to delete files. If like there's no anything you install, even if you uninstall it, there will be artifacts that will be left. There will be some part of that uh, application that will be left on the system. Those are artifacts. So cipher.exe is a inbuilt Windows command that can be used to securely delete data by overwriting it to avoid their recovery in the future. To overwrite deleted files in a specific folder, cipher W drive letter folder name. So to overwrite all the deleted files in the given drive, cipher W drive letter. So, but here to for a specific folder, you uh, you specify the folder. Let's look at the example here. Cipher W. This is the drive letter C. Can be C, can be D, can be then the folder name test. So it will remove all that information. And we can also disable some Windows functionality as an attacker can disable some Windows functionality in order for him to be able to hide all that is done. So you can disable last access timestamp. FSUT is a utility in Windows used to set the NTFS volume behavior. So to disable last access, because that disable last access is one thing that can really uh, uh, rat out the what's it called? Um, I mean the attacker. So he doesn't want that information out. So he wants to deceive anybody that is doing investigation. So disable Windows hibernation using the registry editor power config command. So you can disable last time stamp. Disable also disable Windows thumbnail cache. Disable Windows preferred feature. Last access timestamp of the file contains information regarding the time and data when the specific file was opened. So you can know when it was last modified or opened. So you can disable that so anyone that wants to investigate will not be able to see. Then also you can disable Windows hibernation. It's a evening system file located in the root directory where the operating system is installed. It contains information regarding the system RAM stored on a hard disk at specific time. So when the user selects to hibernate his or her system, the information is crucial as security personnel can use it to investigate an attack on the system. Therefore, disabling Windows hibernation is a crucial step towards covering the attacker can disable Windows hibernation through registry by implementing following steps. Registry editor, double click on hibernate, enable default from right pane, edit the word in value data, enter value of 0 to disable hibernation because it stores things that happened. Because it stores things that happen that attackers don't want that information. Then also we can there are some I don't know if you are using Windows, you would have noticed that something happens, maybe an issue with your system is misbehaving and restore to some particular points, maybe before you did one thing, installed or installed something. So those restore points, The attacker wants to disable it because it will not help what his mission. It will not help his mission. Restore settings. Disable system restore points. The information about hidden data and previously deleted files. It poses a risk for attackers as the deleted files can be recovered from previous restore points. So you can go to control panel, system and security, system uh, protection. The system property dialog appears. The system protection tab, select the drive and click on configure. Under restore settings section, select disable system protection option and click on delete button. So system protection wizard will continue to delete all restore points. So there won't be any restore points. So for you go to control panel, system and security, system protection, system property, system protection tab, figure. Under the restore setting, select disable system protection and delete. Click on delete button. Continue. Click on continue to delete all restore points on the drive, then click OK. Also disabled from the registry. Then artifacts. Attackers often attempt to conceal artifacts corresponding to their malicious behavior to bypass security controls. Every operating system hides its artifacts such as internal task execution artifacts and critical system files. Attackers leverage this operating system feature to consider artifacts such as directories, user account files, folders, or any other system-related artifacts within existing artifacts to evade detection. So, file or folder in the Windows system. Attribute H plus S plus R, then folder name. So admin make directory CHAC. So admin directory. So CHAC is there. But now I want to hide it. Say attribute H plus R plus S CHAC, which was here, but by the time you check now the directory, you can't see it again. It has been hidden. So you can hide that. Also create hidden user account, net user username add, and net user username active yes. Run the following command to hide the account when it is not required. Net user chhacker add. So we have added the account chhacker. Next is net user sorry chhacker active yes. So you have made him to be active. Net user chhacker active no. You have made him to be inactive. So adding artifact in Linux, open a new terminal, use the cd command to navigate to the location of the file that needs to be hidden. CD document malicious file, then prefix a period, the file name to hide it. So like this file name now, once you put a period, a full stop before it, it will hide it. So check whether the above file is hidden using the ls command. The ls will list it. But I use ls -a or ls-al to view all the hidden and unhidden files respectively. Use the following command to create a new hidden folder. So you can create a new hidden folder. Once you just put dot before it, it becomes hidden. So use the touch command to create a file within the hidden folder. Touch malicious file.txt. So once you put a full stop before it, comes hidden. So for Mac operating system, um, write files in Mac operating system. Default to write home.apple.finder app shows all file false. Kill all finder. To hide a specified type file, type ch flags ed. Drag the target file onto the terminal and press return. Ch flags hidden file name. Add space at the end. So that hides a particular file. Have tools that can be used to cover your track like CC Cleaner. Cleans traces of temporary files, log files, register files, memory dumps, and your online activities as your internet history. So, how do you defend? Finally, yeah. How do you defend against covering tracks? Activate the login functionality on all critical systems. Conduct periodic audits on IT systems to ensure that login functionality is in accordance with the security policy. Ensure new events do not overwrite old entries in the log files when storage limit is exceeded. Configure the appropriate and minimal permissions necessary to read and write log files. Maintain a separate login server on the DMC to store logs from critical servers. And regularly update and patch operating system application and firmware. Close all unused open ports and services. Encrypt the log files stored on the system so that they cannot be altered without an appropriate decryption key. Then set log files to append only mode to prevent unauthorized deletion. Periodically back up the log files to unalterable media. You back it up so that they cannot be, even if somebody alters it, then you have the record already. All right, so we are through with that module. Want to look at the next one, which is malware threats. Malware threats. So here we're talking about different malware, talking about introduction to malware. And talk about different types of malware. Malware is just a software with malicious intention. A malware is a malicious software that damages or disables computer systems and gives limited or full control of the system to the malware creator for the purpose of theft or fraud. So that's the purpose of a malware. It comes to damage or for fraud, for purpose of theft or fraud. So it damages or disables computer systems and gives limited or full control of the system to the malware creator for the purpose of theft or fraud. For the purpose of theft or fraud. So examples of malware. We have Trojans, backdoors, rootkits, ransomware, hardware, viruses, worms, spyware, botnets, and cryptas. These are examples of malware. They either damage or disable a computer system, giving. So now, all that we have talked about in system hacking, you may not need to go through all that stress if you can identify and work with a malware that can give you what you need. So that's the advantage that. Malware gives. So if you can infect a uh, if you can infect a place with a device with malware or a network, you may not need to start doing a lot of things. It will take advantage of the vulnerability that exists and be able have you to allow you to establish remote control over the system and all manner of things. You can be able to exfiltrate data and do all manner of things. So malware is malicious software that damages or disables a computer and gives limited or full control of the system to malware creator for malicious activities such as theft or fraud. So malware includes viruses, worms, trojans, rootkits, backdoors, botnets, ransomware, spyware, hardware, scareware, crapware, roughware. This may delete files, slow down computers, steal personal information, send spam, or commit fraud. Malware can perform various malicious activities from simple email advertising to complex identity theft and password stealing. So malware programmers develop and use it to attack browsers and track websites that are visited. They also use it to slow down system and degrade system performance, to cause hardware failure, rendering computers inoperable, steal personal information including contacts, erase valuable information resulting in substantial data loss, attack additional computer system directly from a compromised system, spam inboxes with advertising emails. So how do they enter the system? Through instant messenger application, whether Facebook or any other chat, portable hardware, the USB, browser and email software bugs, insecure patch management, rogue stroke decoy applications, untrusted sites and freeware web application or software, downloading files from the internet, email attachments, network propagation, file sharing services, NetBIOS FTP and SMB, installation by other malware. So some malwares I bring in malwares with them. They can bring in malwares downloaded Bluetooth and wireless networks. So when there is the auto-run malware, so many devices are vulnerable to auto-run malware. So if you have, for instance, on a USB, attackers can place an autorun.inf file with the malware in a CD or DVD or USB device and trick people into inserting or plugging it into their systems. Because many people are not aware of the risks involved, their machines are vulnerable to auto-run malware. The following is an content of autorun.inf. Autorun open setup exe icon setup exe. So the best thing is to turn off the auto start functionality. So you can turn it off in Windows 10, click start, gp edit.ms in the start button and press enter. If you are prompted for an administrator password, type the password or click allow. Under computer configuration, expand administrative templates, expand Windows components and click autoplay policies. You turn it off. You turn off autoplay because that's what allows the malware that is on what's it called on a USB or CD to just come onto your system and it's installed there. So common techniques used to distribute malware on the web um, are black hat search engine optimization, ranking malware pages highly. So there are pages that contain malware. So when you search for anything related to that, it will be high on the uh, what's it called? Search page, search engine optimization. Maybe Google, you may search from there. You want to look at this thing is high, or you click on it, and that becomes an issue. Social engineer clickjacking, tricking users into clicking on innocent looking web pages that could distribute malware, spear phishing, making legitimate institution and attempt to steal login credentials. malvertising embedding malware and other networks that display across hundreds of legitimate traffic sites. That's malvertising. Advertising malware compromise legitimate websites. So if the attackers can compromise a legitimate website so that they upload their malware, then anybody that visits it will then drive-by downloads expecting flaw in browser software to install malware. So this driver download, just visiting a website, malware has been installed on your system. Spam emails, attaching the malware to emails and tricking victims to click the attachment. Attaching malware to emails and tricking victims to click it. Then RTF injection, injecting malicious macros into an RTF file and tricking users to open the malicious documents. Injecting malicious macro into an RTF file and tricking users to open it. So I think we just have to pause and continue on Saturday from here. We'll continue from here on Saturday. Mr. Moses Olusoji, can you hear me?
Yes, I can hear you, sir.
Good evening.
Good evening. Thank you, sir.
Yes, I do hope you have gained